In this lesson, we will learn how to use Spring Security to require that all traffic be conducted within HTTPS. HTTPS is a secure protocol that allows us to encrypt data that is sent between the browser and our web server. This is important when we are sending sensitive information because it prevents the information from being sent in plain text, which is vulnerable to being intercepted by an attacker. So by encrypting our data, if it were intercepted by an attacker, it would be harder for them to glean out the important or sensitive information. In order to encrypt our data, HTTPS uses two secure protocols, SSL, or Secure Sockets Layer, or TLS, Transport Layer Security. Now, TLS is the most recent secure protocol that we'll be using within this lesson. In order to create a secure session with HTTPS, we need to create a public key for our application. So we're going to use Java's key tool to create a public key which will be used to create the SSL handshake. In order to create our key, we'll need to navigate to a command prompt, and we are going to use the key tool within the JDK. So we'll issue the key tool command, and then we're going to use the gen key command within the key tool. Next, we're going to specify an alias of Tomcat, and then we need to provide a key password. So we're going to set our password to password, and then we need to specify the name of our key store, which we're going to set to keystore.jks. Next, we'll set the key store password using the store pass option, and we're going to set that also to password. Next, we need to specify the key algorithm to use, and we're simply going to use RSA, and we'll need to specify the validity, which we're going to set to 360, and finally the key size, which we'll set to 2048. Now, once we execute this command, it's going to ask us for some information. So I'm just going to provide a little bit of information here. It's going to ask you about your organization, your city. I'm just going to say USA, and I'll keep it real general here. And then finally, it's going to ask you to confirm this information and just type a yes. And then your key is going to be generated. So you can see that mine was put in C users Kevin Bowersocks, and it will have the name keystore.jks. So we're going to navigate back to STS, and the next thing we need to do is make sure our server is stopped. This is very important because we're going to change some of the configuration within our server. So once the server is stopped, we'll navigate to the Package Explorer, and we will expand the servers and our pivotal TC server, and then we're going to enter the server.xml file, and we're going to make some adjustments to this connector tag. So the first thing that we're going to do is we're going to enable SSL using the SNL enabled attribute, and we'll set that to true. Next, we need to point to our key store file, and remember mine was in C users Kevin Bowersocks, and then it was named keystore.jks. Now we're going to specify the key store password, which was equal to password. Now we need to specify our scheme, which is going to be equal to HTTPS. We need to set the secure attribute to true. We need to specify that we are not performing client-side authentication. And then finally, we need to specify our SSL protocol. And that's going to be equal to TLS version 1. So at this point, our server.xml file is configured to enable HTTPS on our TC server. Now we can navigate to our security context.xml file. Within this file, we need to make some changes to our intercept URL tag. So we're going to navigate down to these tags, And we are going to specify the requires channel attribute. And we have a few options here. If we look at the attribute, we can specify HTTP, HTTPS, or any. So in this case, we are going to specify HTTPS, and we will just copy that attribute and its value, and we're just going to add it to each one of our tags. So we're going to be requiring that all communication for our application be conducted in HTTPS, and you do see this quite frequently. So we'll now save our securitycontext.xml file. Next, we will restart our server, and then once our server has started, we can navigate to the application, and we'll notice if we try to access the application via port 8080, we'll have issues. However, if we attempt to use HTTPS, we will then be transmitted over to port 8443, and we can access our application. So there we see we are accessing the application via HTTPS, and that was through the configuration of our Tomcat server, and then using the requires channel attribute within Spring Security on our intercept URL tags. And that attribute forces all traffic to those particular paths to a particular protocol.